Hi, thank you very much, Claire, for the introduction, and welcome everyone to this second module of getting ready to teach international A-level chemistry. As Claire mentioned, and you should be able to see on your screen at the moment, I am the presenter for today's session. My name's Cliff Curtis, and I'm sure that this is a follow-on from yesterday's module. Before I get started on today's session, there was a question raised yesterday to which I did not know the answer, and I've now found out. It was how the A star is awarded at international A level. A candidate must get at least 480 uniform marks at IAL, but also must get at least 270 marks out of the 300 in the 3 A2 papers. That's papers 4, 5, and 6. If they meet those two criteria, then they can be awarded A star. Okay, so I hope that answers that particular question. And apologies that I didn't know the answer immediately yesterday, but at least I've managed to find out. Okay, so let's move on today to the aims and objectives of this particular session. It's first of all to understand the question types for this particular qualification, and then to understand the assessment objectives for this qualification to find out why we actually have them, why we use them, and how they actually work in exam paper writing. The next thing is to provide you with some practice using the mark schemes using exemplar student work. This is student answers that have been taken from the examination papers that were sat in May and June of this year. So they're very recent student answers, and they are real student answers. They're not ones that I've made up. They're ones that I've taken off the electronic markings system that Pearson have. And then lastly, to learn about the support that's provided by Pearson around assessment, which will be a little bit of recap of what I mentioned yesterday, but also mentioned a couple of other things as well. Okay, so I will deal with this in the following area: question types, assessment objectives, then look at A2 questions, AO2 questions, then look at AO3 questions, and then look at the support. Don't worry at the moment if you have no knowledge of what AO2 and AO3 refer to. There is an AO1, and I'll discuss why we're not looking at AO1 questions later. If you weren't present at yesterday's session, then you may not be familiar with the assessment objectives, but I'll go through all of that again. Okay, so first of all, looking at the question types. The following question types will be set in units 1, 2, 4, and 5. These are the theory papers. Units 1 and 2 are the theory papers of AS, and 4 and 5 are the theory papers of A2. There will be multiple choice questions with 4 alternative answers labelled A, B, C, and D. There will be 20 multiple choice questions in each of those papers, and they will be at the very, very beginning of the paper, and will be consecutive. Before we get into looking at short response questions, they will have a mark range of 1 to 5, but there's also an extended writing question worth 6 marks, but they only appear in units 2, 4, and 5. They will not be in unit 1. They have a particular method of marking, and I will go through that particular method of marking in a moment. And of course, there will be calculations. Chemistry is a mathematical subject, and there will be a significant number of calculations involved. So students need to develop their mathematical skills as well as their chemistry skills. The questions in units 3 and 6 will focus on practical skills. Unit 3 is the experimental skills for AS, working on the setting questions on everything they've dealt with in units 1 and 2, and unit 6 is the A2 experimental skills paper, and that will be largely working on what they've dealt with in units 4 and 5, but also, of course, as I mentioned yesterday, the tests for cations, anions, gases, and organic functional groups that are met in units 1 and 2 will also be tested in unit 6. There's a typical multiple choice question, and the way the students are expected to answer it is by putting a cross in the box. If they want to change their mind, then they put a line through the box and then put a cross in another box, and the one that has the cross in it will be the one that will be considered for marking. There's a typical short response question. This one's only worth 2 marks, but you'll notice that there have been 6 lines left for marking this. For the student's writing, sorry, not for marking, for the student's answer. This leads many candidates to think that in order to be able to gain the 2 marks, they have to fill up all 6 lines. This is very, very far from the truth. The reason why we've left 6 lines is to give an opportunity for those candidates who realise that their first answer that they've put down is in fact not correct, and they decide to cross it out. And hopefully, if they haven't filled up all 6 lines, they've got some space left to put in the answer that they would like to be considered for marking. If they have filled up all 6 lines and they've got no space whatsoever in order to be able to put down an answer that they want to be considered, in other words, they're going to cross out everything they put in those 6 lines, then they'll have to find a space somewhere else on the paper for their answer. But they must make a note here on this particular section of the exam paper to the effect of see answer on page 20 or whatever page it is. And then that will be enabled to be seen by a senior examiner and considered for marking. If they don't put down a note saying that there's an answer elsewhere on the script, then it's highly likely that that will not be seen. And therefore, if there's work there that's worthy of credit, then they will probably not get the credit for it. Okay. Yeah, I was just having a look, see if we were, if anything in the chat box is relevant to me, and it's not, so I will move on. Okay, there's a typical extended response question. Explain how the conditions used affect the rate of reaction and ensure that the propanoic acid is the only organic product. And you see it's worth 6 marks. Now you notice at the top left-hand corner of B in brackets, there's a star. And that means that it's one of the questions that are marked in a particular way. And I'll show you the way. There will be what the examiners call indicative marking points written down in the mark scheme, and there's usually 6 of them. And if all 6 indicative marking points are seen in the candidate's answer, then they will get 4 marks. If there's between 5 and 4, they get 3 marks, and you can see it works on a sliding scale. Now, the first thing you're now thinking, if you're not familiar with this, is where are the other 2 marks going to come from if the student has got all 6 indicative points? Well, there, first of all, are the indicative points. Okay, there's only 5 of them listed there. I'm not sure where the 6th one's gone. I must have left that off. My apologies for that, but there should have been 6 indicative points there. Okay, I'm not particularly interested in what those are because we're not going about marking this at the moment, but you're wondering where the other marks come from. Well, they come from what we call lines of reasoning. And you'll see, if you look at the middle column there, if we go down to that, the number of marks awarded for structure of answer and sustained lines of reasoning. To get 2 marks, the other 2 marks, the answer shows a coherent logical structure with linkages and fully sustained lines of reasoning demonstrated throughout. So in other words, the answer that they're writing down, to put it in its simplest, it makes sense. It makes chemical sense. Okay. If the answer is only partially structured, then they'll only get 1 mark. If there's no structure into the answer, they get 0. Now, that doesn't mean that they can't use bullet points. There's nothing wrong with using bullet points, but providing, of course, the bullet points are put down in a logical order to answer the question. And so effectively, if you move from one bullet point to the next bullet point, you can see that there's a logical argument developing. There will be some sustained lines of reasoning, as we say, okay? And you can see over there in the right-hand column, in general, it would be expected that 5 or 6 indicative points would get 2 marks, 3 or 4 would get 1, and if they've got 0, 1 or 2 indicative points, they're likely to score just 0. But notice the next paragraph. If there's any incorrect chemistry, deduct marks from the reasoning. If no reasoning, marks awarded do not deduct marks. Okay, and the next comment is for the examiners and not for you. Look for indicative marking points first and then consider the mark for structure. Okay, which is obvious. Now, before I move on, there's something coming to the chat and I'll see if anything applies to me. Okay, all right. No, it doesn't. It's all about trying to get the resources because people can't see the resource button. That's okay. So let's move on. Okay, there's a typical calculation. This is unusual because normally an equation would be given so that the examiners don't have to mark from an incorrect equation. But you'll notice on this particular instance, they ask him for the equation first. So they write down an equation for the decomposition of sodium azide, and then they calculate from oh, wait a minute, a passenger airbag requires 150 dm cubed. Oh, no, so they don't need the equation to answer that next bit. So they write an equation first of all, and then there's a calculation, 125 cubic decimeters of gas to fill it. Oh, yes, they do need the equation. You calculate, using the ideal gas equation, the mass of sodium azide required to fill the passenger airbag. So what they will have to do is to go back to their equation and look at the mole ratio in their equation between sodium azide and the gas given off, which of course is nitrogen. Use that molar ratio to work out the number of moles, first of all, of nitrogen, and then relate that to the number of moles of sodium azide needed to give that number of moles of nitrogen and do the calculation. That is a good calculation there, and virtually all calculations will be AO2. The only calculations that are going to be AO1 would be very simple, straightforward calculations, like calculations of relative molar masses, because that's not considered to be particularly demanding mathematics. Unless, of course, it's present within a larger calculation, it might be considered to be AO2. Okay, all right, here's an activity for you. This was there yesterday, but I'm guessing that there's probably some people that were not here yesterday. So those of you that were here yesterday will know the answer to this one. If you weren't here yesterday, then it's a new one. And I will explain why I'm asking for this particular type of question, asking you to do this. Don't write anything in the chat box, please. There's too many of you here for us all to see the answers. There's over 40 of you here. So we can't see all the answers, of course. So just have a think about this or jot them down on a piece of paper. What are the essential points to include when answering the following 2 questions? Right, the dot and cross diagram for that, and explain the shape of the molecule. 2 marks for the first one, 3 for the second bit. So have a think about that, and then I'll explain why I'm asking you to do this exercise. Okay, first of all, let me explain why I've asked you to do this particular exercise. I started examining papers in 1984 and finished in 2017. So I marked examination papers for various awarding bodies, mostly Pearson EdXL, for 33 years. That's every single year and sometimes twice a year for 33 years. I saw thousands and thousands of examination scripts and obviously tens of thousands of answers. And I've got used to seeing many candidates starting off answers and then realizing they've made a mistake and then crossing out, rewriting, running out of space and going up and down the sides of the paper and all sorts of things. And I thought to myself, how can I try to get my candidates to avoid that particular problem? And so what I tried to train my students into doing was to say to themselves, before they start answering a question that's worth 2 or more marks, to get clear in their head, just spend 20 seconds, 30 seconds at most, getting clear in their head, what are the major points they need to put down, and then start writing their answer. So the major points they need to put down here for the dot and cross diagram are the bonding pairs and then the non-bonding pairs on both the oxygen and chlorine atoms. So once they got that clear in their mind, away they go. The next one, they need to write down the shape of the molecule. Then they need to consider the regions of bonding electrons repel one another to adopt the positions of minimum repulsion. So once they've got that clear in their head, off they go. And I found that when I was marking their mock papers or any past papers that I give them for practice, there's far less of this starting off wrong answers, crossing out and rewriting than before I started having this particular exercise. So it's something that you might like to consider with your students. Okay, here's another one. What's the answer to the following question? Why is iodine very soluble in cyclohexane, but it's only very slightly soluble in water? So have a think about what are the essential points that you need to be considering there, and then obviously construct an answer there. Why is iodine very soluble in cyclohexane, but only slightly soluble in water? This is a question that's been asked on the past paper, of course. Now, what I would hope my candidates, if I were still teaching, I retired 13 years ago, so I'm no longer involved in teaching, I'm just involved in teacher training. What I would hope my candidates would be thinking before they put their pen to paper would be, right, what type of substances are we dealing with here? Iodine, molecular, non-polar. Cyclohexene, molecular, non-polar. Water, molecular, polar. Ah, right, so I've got iodine and cyclohexane, both non-polar, like with like. I've got over here water non-polar. Now, what's so special about water and the intermolecular forces of attraction between them? Ah, hydrogen bonding, as opposed to iodine and cyclohexane, which of course will just simply be London forces. So I would be looking to write an answer in terms of London forces and hydrogen bonding, and I would hope that that is the answer my students will come up with. That cyclohexene and iodine form London forces between the molecules, so iodine is soluble. Like dissolves like, basically. And then hydrogen bonds between the water molecules are much stronger than the London forces between iodine and water molecules, so iodine is less soluble in the aqueous layer. So can you see where I'm coming from with regard to this? And that is to try to get students to think about what are the essential points that they need to get into their answer before they start writing. It may be an exercise that you think may be worthwhile trying to install in your students. I leave that entirely up to you. Okay, so let's move on now and start talking about assessment objectives and what are they and why do we use them? Why do the examiners use them in writing exam papers? Well, we have them to help make the exams fairer year on year, and I hope the subsequent slides will explain how the assessment objectives do in fact achieve that. We also have them to provide structure for the question paper writers, and I think that will become clear in the subsequent slides. And we also have them to make sure the exam's about skills and not just about knowledge. Again, I think that will become clear in the follow-on slides. It also provides both you and your students about some reassurance about the types of questions that they will actually be asked. They will never know, of course, what topics will be tested on any particular paper, now that, of course, we're over COVID restrictions. But they will at least know the types of questions that we're going to be asked and the percentage of those types of questions that will be asked, as we'll see in a moment. Okay. So what are the assessment objectives? Well, there are 4 of them effectively. There's assessment objective 1, AO1, which is all about demonstrating knowledge and basic understanding of science. So all of those statements in the specification that say students should know that, any one of those statements can be tested as an AO1 assessment objective question. Basic understanding, so that would be simple understanding of things that are actually present in the specification. Like, for example, draw a dot and cross diagram of the water molecule. That is mentioned in the specification, so that would be AO1. Explain the shape of the water molecule. Well, that is mentioned in the specification, so that would be classified as AO1. Okay. AO2A, and you can see AO2 is split into 2 parts. AO2A is about the application of knowledge and understanding of science in familiar and unfamiliar contexts. So this is where they have to take what they have learned and understood from your teaching and apply that to both familiar and unfamiliar contexts. So if they were asked, for example, to explain the shape of the hydrogen sulfide molecule, that would be classified as AO2A, because hydrogen sulfide is not mentioned on the specification, but water is, and so they should apply their knowledge of water to hydrogen sulfide to come up with an answer. AO2B is about the analysis and evaluation of scientific information to make judgments and reach conclusions. So this is where within the question there will be some information supplied, and the students are expected to use that information to reach a conclusion or to make some form of judgment. AO3 is all about experimental skills in science, including analysis, evaluation of data and methods. And AO3 is tested solely in Units 3 and Unit 6. There is no AO3 testing in Units 1, 2, 4, and 5. That doesn't mean that there won't be any questions on experimental skills, but the questions will be targeted at AO2A and AO2B with a little bit of AO2, AO1. So they won't be specifically targeted at experimental skills. Okay. So what type of questions do we get? Well, AO1, questions requiring students to recall and use information that you've taught them. AO2A, questions requiring students to apply what you've taught them or to use the skills they've developed. AO2B, questions requiring students to analyze and make judgments. And AO3, questions on practical work associated with practical skills, such as planning, drawing graphs, analyzing data, and evaluating methods. Right, now what I'm going to do now is go through and give you some examples of some typical AO1, AO2A, AO2B, and AO3 questions, and then ask you to carry out a little exercise in which I want you to try and identify whether specific questions are targeting AO1, AO2A, AO2B, or AO3. So let's have a look at a typical AO1 question. There is one there. Covalent bonding is mentioned on the specification as the electrostatic attraction between 2 nuclei and a shared pair of electrons. Now, since it's mentioned on the specification as something the student should know, that of course is AO1. Draw an electron density map for an oxygen molecule that is listed on the specification, so that is AO1. Draw a diagram to show the shape of the water molecule and give the bond angle. That is mentioned on the specification, so it is AO1. Here's a typical AO2 question. what is the electronic configuration of the scandium 3+ ion? Now, that is not mentioned on the specification, but of course, candidates are expected to know the electronic configuration of the first row transition metals, so they should then apply their knowledge of the electronic configuration of the scandium atom and then say which 3 electrons are going to lose to form the 3+ ion, and therefore deduce the electron configuration of the scandium 3+ ion. So that is classified as AO2A because they have some work to do to come up with the answer. There is a calculation. Use the Hess's cycle data to calculate the enthalpy change for the thermal decomposition of magnesium carbonate are shown. Calculate the enthalpy change for the thermal decomposition of magnesium carbonate. Okay, so it's a straightforward exercise in putting the numbers into Hess's law and coming up with an answer. So that is AO2A as well. Here's an AO2B question. What is the best estimate for the relative atomic mass of silicon in this sample? So the students are not given a scale on the vertical axis, and therefore they have to make estimates of the relative percentages of 28, 29, and 30 and come up with an answer to the relative atomic mass of silicon. So that's classified as AO2B because they have to take the data, analyze it, and reach a conclusion from that data. There's a typical AO3 question. I don't expect you to read through all of that. I think you can quickly see that that sort of question is a question that would be set on a Unit 3 paper because it's all about investigating organic liquid that was an alcohol of formula C4H10O. It's a lovely question, I've got to say. I've used this question in some of my training in the past. So you can see, if you just quickly read through what they're asked to do in numbers 1, 2, 3, 4, and 5, you can see that everything is all about experimental skills. Okay, so that's where I now hand over to you. Again, please don't put any answers into the chat box. We're now approaching nearly 50 of you in there, and obviously we can't, there's no point in analysing nearly 50 answers, but you may want to jot down the answers to these on a piece of paper, because all of these questions are in the PDF version of the slide pack they're in the resources. And you may want to start using these with your students. I'll explain why later, that I think it's quite useful for them to have an awareness of what particular assessment objectives questions are targeted. Not so important in multiple choice, but certainly important in others. Okay, without further ado, what assessment objective do you think that question is targeting? Well, hopefully that you've come up with AO1, because the use of methyl orange is an indicator that the colours involved in it are mentioned on the specification. Next one. Well, hopefully you remembered that calculations are classified as AO2A. So that particular multiple choice question is targeting AO2A. Next one. Well, hopefully you've spotted that they have to analyse the data given to reach a conclusion about the percentage uncertainties here and the total uncertainties. So that's in fact AO2B. Here's the next one, and there are two parts to part A and two parts to part B, and each of them have a separate assessment objective that may be the same or different from the others. Question to ask yourself every time is, are they expected to know this from information that are contained within the specification? If they are expected to know it, or it is just simple, straightforward application of knowledge, it's AO1. Other than that, it will be AO2A or AO2B. There's nothing here on the practical section because this is taken from a theory paper. Remember that there are never AO3 targeted questions on units 1, 2, 4, and 5. So, are the students expected to know, excuse me, the second type of reaction here? Yes. So it is AO1. Suggest why neutralization does not occur in an open container of baking powder, where the students have to analyze the data that's been supplied there to reach a conclusion. So that is AO2B. Calculating empirical formulae will always be AO2A because calculations are AO2. And here, right in that equation, a lot of chemical equations will be AO2A, but this one was considered to be very, very straightforward. Okay, so it was actually classified at the end of the day as AO1. Now, particularly as state symbols were not required there. It's a very simple equation to write there. At least it should have been for the majority of candidates sitting in an A-level exam. So that was actually classified as AO1. And then that, just have a quick read through that, okay, through A, B, and C. And I think you'll very, very quickly realize that that's a question that's been taken from Unit 3 paper. And if it's taken from a Unit 3 paper, everything must be AO3. Right, besides assessment objectives, there is something else that is exceptionally important here. Okay. And that is command words. All the questions in exam papers are designed to use a specific command words to guide the students. The command words represent a range of skills, like simple recall, give, name, state, using knowledge, describe, given reasons, explain, provide more details analysis, evaluate, and justify, show particular skills, calculate, plot. Where do you find these command words? Well, in the specification that is provided on the Pearson website, if you go to Pearson qualifications and then scroll down to international advanced level, and then click on chemistry, and you will be taken to the international A-level website, and then you'll see on the right-hand side of the landing page, you'll see specification and sample assessment materials. And if you click on that, the specification comes up, which you can then download. And one of the appendices at the back of the specification has got all of the command words listed. And one of the things I always said to my students is download that, print it off, and stick it into your folder. And every time you get a question, look at the command word, go to the list of command words, and find out exactly what it is that you're expected to do in answering a question with that command word. There's a couple of things that perhaps I can mention here is that if you are familiar with the previous qualification that we had, the previous specification, then you'll notice that in those past paper questions, the examiners were allowed to use two command words in the same sentence. So you will see some questions that say state and explain. Now, the examiners are no longer allowed to use two command words in the same sentence, so they can't say state and explain. So the word explain could actually mean state and explain. Let me give you an example here. Explain how the rate of the reaction between magnesium and hydrochloric acid changes when the concentration of hydrochloric acid is increased. Now, the candidates here are not told how it changes, so the first thing they need to do is to state how it will change. So they write down the rate of the reaction will increase, and then they give their explanation. Explain, however, may not need a statement to be made, a statement to be made. So the question could be, explain why the rate of the reaction between magnesium and hydrochloric acid increases when the concentration of hydrochloric acid increases. Now, this time they're told, so all they have to do is to give an explanation. The other thing that's quite useful, and I think it might be worthwhile you going through some of these command words with your students to point out the subtle differences with some of them, like, for example, deduce and determine. There is a difference between the two, and when you have a look at them now, you'll see for yourself the difference. The major difference is that when the command word determine is used, the candidates need to have some element of a quantitative explanation in their answer. It could be in the form of, say, of a calculation or just a simple sum, but something of quantitative nature needs to be there. So I think it's a very useful exercise for the students to download those command words and print them off and put them into their folder. Okay. Is there actually a link between command words and the AOs? Well, yes, I think there is. And that's the sort of link. This is not an exhaustive list, but just gives you a few. So when you see these sort of command words, then the students can get an idea, and you can get an idea of what assessment objective is actually being assessed here. I'll leave you just to have a quick look at some of those. Again, you can have a closer look at them when you look at the PDF version. And you'll notice when I mentioned, some of you may have been surprised that that equation earlier was AO1, write a familiar equation, or an equation that is very, very simple to deduce is AO1, but unfamiliar or more complicated equations will be AO2. Okay, AO2 questions. Let's have a look at AO2 questions. Why am I not going to look at AO1? Well, it's all about knowledge and basic understanding. It's one really that you can't influence very much. The students either go away and learn what you teach them, or they do not. The students should still recognize AO1 questions and not spend time going beyond AO1. Again, my experience as an examiner has shown me that many students, when they see the word explain, think that they have to write as much information as they possibly can and put it into filling up all the space that's been made available. And if the question is targeted at AO1, it's a very, very simple piece of chemistry. And all they're expected to do is to give the minimum of explanation there. So they shouldn't go beyond the requirements of that. And what happens, of course, is that when they do that, is they start wasting their time. And they come out of the exam, and the first words they will say to you is, I didn't have time to finish. The exam was too long. They shouldn't have set as many questions as that. And when you analyze their work, when you look at the paper later, which you can do by using Results Plus, you'll find that they've written far too much in answering some of these what were supposed to be very straightforward questions. And that's why they didn't get to the end of the paper. So it's well worthwhile students knowing which questions are targeting AO1. So that's one of the reasons why I think it's quite useful for students to be made aware of AO1, AO2A, AO2B, and questions. AO3 are obvious because they're units 3 and 6. Simple as that. Okay. So let's move on now to another activity for you. So let's get you involved in performing an activity. I'm going to ask you to use the mark schemes on the screen to mark the student responses in the next slides. We're going to go through each question one at a time. Before we do that, there's just something come up on the chat screen here, and I can't get my mouse go down onto my tablet. I've got it. Okay, let's have a look at what's on here. I have a question about the ideal gas equation. I have noticed it's always given in brackets in the exam questions. So will this equation always be given to students in exam questions? Yes, it should always be given, and also along with the value of the gas constant R. You may have noticed, however, that in paper 1 this year, they forgot to put in the value of R, which was a mistake, but allowances were made when those papers were marked, and students got credit for any value of R that they put in, whether it was correct or incorrect, providing they did the calculation correctly. That was a mistake made in the writing of the paper, an error made probably at typesetting, that it was missed out. Okay. Okay. Question that we're going to have a look at. This question is about silver. Silver chloride decomposes in light. The reaction was first used in photographic dates. Useful information, but doesn't help you to answer the question. Write an equation for this decomposition, including state symbols. Okay, so the answer is correctly balanced equation and then correct state symbols. There's the correctly balanced equation. But notice that M2 is dependent on M1 or a near miss. So if they make a minor error in one of the formulae, then they can still have M2, okay? But if the formulae are incorrect, or correct formula and balanced equation, they can have the state symbols. But if all the formulae are incorrect, then they won't get that particular second mark. Okay, so let's have a look at the first one. Now, all I need you to do is to jot down on your piece of paper. Please don't put anything down in the mark scheme, because you won't get any credit for it. Right, and there are too many of us to see the answers. Just decide for yourself. Jot down on a piece of paper. Student 1, how many marks? Student 2, how many marks? Student 3, how many marks? And student 4, how many marks? So it's going to be 0, 1, or 2. Right. Student 1, 1 mark. Incorrect state symbol for silver chloride. Should be solid, not AQ. Student 2, 1 mark on the near miss basis. They've got an incorrect formula for silver chloride, but all the state symbols are correct. So they don't get the first mark, but they do get second on a near miss. Student 3, 2 marks. Untidy presentation, but I think we can assume that the state signs are correct. Note the S crossed out for chlorine and replaced with a G. The rules of marking are that work crossed out and replaced what's replaced should be marked, what's crossed out shouldn't be marked. The other interesting thing is that work crossed out and not replaced should be marked. So if they'd put down G, crossed it out and not replaced it, they would have still got it. Okay, the last one, just 1 mark because you've got an incorrect state sign for silver, AQ, instead of solid. So 1, 1, 2, 1. Okay, that's a nice little starter. Let's have a look at the next question, which is a calculation, okay, which again obviously targets AO2A. You're given relative abundances of 4 isotopes. The first mark is for getting the correct expression there. And the second mark is for the evaluation and the answer given to the 3 significant figures, because that's what's required in the question itself. So example of the calculation, they multiply each of the relative isotopic masses by their relative abundance and divide by 100. That gets the first mark. Okay, they will also get the first mark if they simply wrote down 28.1586. That would get them the correct mark because, of course, the only way in which they can get 28.1586 is by using the correct expression. So that 28.1586 subsumes the correct expression and then given the final answer to 1 mark, 28.2. Okay. Correct answer with no working scores full marks because those are the Ofqual regulations for UK exams, and we follow Ofqual regulations in international exams so that the exams are considered to be equivalent to the UK. Allow grams per mole as a unit, okay, because it does say calculate relative atomic mass. I mean, relative atomic mass, technically speaking, doesn't have units, molar mass has units, but relative atomic mass doesn't. So they're overlooking that. So allow them if they put down that particular unit, because really we're interested in the calculation here. But if they give a different unit, then that's not going to be allowed. Okay. All right. So there's your first calculation. How many marks should be awarded to that? Once again, don't put down any answers in the chat box. Just simply put them down on your piece of paper. Again, the reason I'm asking you to put the answers down is that you might want to use these with your students and get your students to do some marking. I think you can quickly see that they only scored the first mark here, not the second. So there's just 1 mark because the final answer has not been given to 3 sig figs. Okay, have a look at the second one. Shouldn't take us very long to realise that 28.2 is the correct answer, so scores 2 marks. They're given a unit of grams per mole, which of course is the only unit that's allowed. So that scores 2 marks. Student 3. One mark, correct expression, incorrect evaluation. It's 28.2, not 28.3. So only 1 mark. Interestingly, if their answer had been 28.3, and that's the only thing they put down with no working, they'd scored 0. Incorrect answer with no working, 0. Again, correct answer, 28.2, 2 marks. Nothing else to be said about that at all. Okay, this time, instead of putting down 91.07 and 46.2, etc., divided by 100, they divided the percentage abundances by 100 and used those to multiply, which is a perfectly acceptable way of performing the calculation. Okay, the next one, explain the trend in first ionization ranges of aluminium, silicon, and phosphorus. Now, here's another example, of course, of where the first thing they have to do is to state what the trend is, and that is that it increases. Why does it increase? Because electrons are being removed from the same subshell, except being removed from 3p subshell. Subshell is in brackets there, so except removed from 3p is okay. Or as an alternative in the additional guidance column, allow they have the same shielding, ignore the same shell or same orbital, okay? They don't, of course, have identical shielding, but they do have identical inner shielding. Don't forget that electrons within the same orbital also shield one another because there's electron-electron repulsion between electrons in the same orbital. So technically speaking, having the same shielding is not correct, which is why it's an allow and not an accept. Okay, so it's where the examiners are being generous. Ignore same shell or same orbital. Okay, they need to specify it's 3p, not just the same orbital. That's not good enough. And then the last thing is because they have the number of protons increase, and by one for each element is in brackets, so it's not necessary in the answer. Just the number of protons is increased is all that's needed. Accept increased nuclear charge in the additional guidance. Okay, right, so I kept the mark scheme on the slide so that you can see it. There is your first question. Okay. See if you can pick out the important marking points within that question. Yes, I can repeat the shielding part. If you look at those electronic configurations for student one there, can you see that there's only one electron in the 3p orbital for aluminium, but there are two in the 3p orbital for silicon? Therefore, the electrons in the 3p orbital for silicon are not experiencing the same shielding as the 3p orbital in the in aluminium, because there is an additional repulsion between the two electrons in the 3p orbital for silicon, because the two electrons repel one another, and shielding is electron-electron repulsion. I wish the word shielding was never ever used, and all we ever talked about was electron-electron repulsion. Okay? A number of textbooks do not make it clear that shielding results from electron-electron repulsion. It's a word that perhaps should never ever have been used, but unfortunately has come into common existence in chemistry language. Okay. There was a question about the previous one. What does it mean when it says transferred errors minus slip in final answer 28 to 30? Right, if they've made a minor error in, say, transcribing the numbers that are given in the table into their calculation, so they've, instead of taking 91 point whatever it was, 06, they've taken 91.60. If their final answer then still turns out to be 28 and 30, between 28 and 32, then they can have a second mark as long as they've done the calculation correctly and evaluated it correctly and put to 3 decimal places. That's what it means. Okay, I hope I made it clear what I mean by shielding here, that the shielding is not the same, because shielding is the result of electron-electron repulsion. And electrons within the same orbital, if there's more than one, repel one another. So that is effectively what is termed shielding. I tear my hair out when these phrases crop up. Shielding. What does shielding mean? It's never explained in some textbooks. I hope I've explained it in the textbooks that I've written to support this particular qualification. I hope if you've got the student books supplied by Pearson, you'll have noticed my name on it. and I dealt with this particular topic. And I did try to talk about electron repulsion, and the word shielding is often used in that particular context. I didn't use shielding in my teaching at all. Never used the word ever. Okay, so let's mark this one. Okay, we've got ionization energies generally increase. So that's MP1. Okay, but I'm reading through the rest of that. I can't find enough information to give MP2. So I'm going to mention, there's no mention of number of protons for MP3. So all I'm going to do is give that 1 mark. That's my version. Okay, there's another question come up into the chat box. Got it. Thank you. Yeah. More than welcome. Okay, so let me close that up and then move on to the next one. Okay, again, I've left the mark scheme up there for you. Okay. As you go through reading this, you will have realized that ionization energy increases. So you've given that mark there. Increase in number of protons is the third marking point. Now have a look to see if there's enough information toward the second one. Because the electrons are removed from the same shell, etc. Is there anything there? I don't think so. That's my own personal opinion. So I'm only given 2 marks. Okay, hope you agree. There's the student 3. First ionization increases, MP1. Have a look at the second line. Can you see more protons? MP3. Shielding remains relatively constant. That's a better term than the same. That's even better answer than the same. Relatively constant. It's not bad, actually. Okay. It does increase very slightly as you go from aluminium to silicon to phosphorus, because of course you are adding electrons into the 3p orbital. So there's a slight increase, but relatively constant is even better. So excellent. So 3 marks. Lastly, student 4. Well, I've never known what is really meant by effective nuclear charge, and it's a term that I never ever used in my teaching. In 38 years of teaching, I never used the term effective nuclear charge, and I see no reason why it should ever be used, but that's my own personal opinion. Okay, it doesn't mean that you shouldn't use it if you know what is meant by effective nuclear charge, whereas I don't, and that's fine. Okay, and no, there's no need to tell me if you think you know. But they have gone on to say that number of protons increases, MP3, and right on the very bottom line, they've got the correct order. So that one scores 2 marks. Okay. Right, well, the next thing we're going to do is we're going to have a look at AO2B. We've reached halfway through the presentation, okay? And as I mentioned yesterday, now that I've reached the tender age of 73 years, sitting down for 2 hours non-stop does not do my circulation very much good. I need to get up and just have a little stretch for a few minutes. So if you will bear with me, then we'll have a little break for, let's say, 3 minutes. It's just coming up to 10 o'clock now. I'll start again at 3 minutes past 10, if that's okay. I hope you'll bear with me just so I can stretch my legs and get the circulation going again. Right, 10 past 3, 3 minutes past 10, we'll start up again. giving me that little opportunity to stretch. Thank you for your patience. Let's now move on and have a look at AO2B, some AO2B questions, and give you an opportunity to mark some of these. Here we've got pure silver cups are too soft, so small amounts of copper added to make an alloy. Okay, explain why copper makes silver less malleable. Explanation that they want to see, the examiners want to see, is the layers or the ions or the atoms slide less well over each other. I always find it quite amusing that metallic bonding is described as the metallic structure is described as cations and delocalized electrons, and yet whenever it comes in the vast majority of student books and textbooks, the moment you start talking about alloys, they start talking about atoms. Okay, I've never ever personally, just another little one of my groans here, I've never understood why metallic bonding is described as ions and delocalized electrons. To me, it's atoms and delocalized electrons. And the metallic bonding is the attraction between the nuclei of those atoms and the delocalized electrons. I often ask some of my colleagues two questions. One, what is the charge on the ion of chromium in metallic chromium? And they say, oh, I don't know, 3+. And I said, oh, what's the size of the 3+ ion? And someone looks up the ionic size and they say, what's the metallic radius of chromium? And they find out it's considerably larger. And I say, well, how can it be a chromium 3 ion? And the other question I often ask them is, what's the charge on the carbon ion in graphite? Oh, they're not ions, they're atoms. But there are delocalized electrons, so surely there must be ions, just like they are in metals. Oh, no, it's totally different. Why is it different? We've got delocalized electrons. So surely there must be ions. No, they're atoms. Oh, well, then they're atoms in metals then, because they're delocalized electrons. No, they're ions. Well, what's the difference? Oh, they're different. What's the difference? I never get an answer. Anyway, moan over. Okay, so you notice that they're allowing the layers or the atoms slide less well over each other. Over each other is in brackets, so they don't need to, it doesn't need to be present. But do you notice in the additional guidance, it says, do not award the layers cannot slide over each other. Okay, and then because the copper ions or atoms are smaller than silver ions or atoms, allow copper ions and silver ions have different sizes. Do not award just copper is smaller than silver. They must have something in their answer that is suggesting they're talking about ions or atoms, okay? Ignore comments about strength of metallic bonds or just copper ions disrupting the lattice. That's just ignored. If they add information along those lines, you just ignore it and don't penalise. Okay, so there's your first question. Again, I've left the mark scheme up on the screen, so you can use it to work out where you think marks can be awarded there. So you're looking for layers or atoms or ions slide less well over each other, and you're looking for copper atoms or ions are smaller or have different sizes. Right, so you see, not very good English, and I often get asked this question, do you penalise poor English? No, providing, of course, it makes sense. And the layers between the atom, should be atoms plural, of course, but we're going to ignore that, don't slip much easily. That's not good English, but it's pretty obvious that the candidate knows that then don't slip very easily, and therefore we're going to allow MP1. I can't see any mention there of relative sizes of copper and silver atoms or ions, so I don't think MP2 scores there. Therefore, I'm only going to give it 1 mark. So I hope that answers the question that I constantly get asked is, do we penalise poor English? No, providing the chemistry makes sense. It's as simple as that. Okay, there's the second one. So we're looking for layers or atoms slide less well over each other, and we're looking for different sizes of ions. So different size of cations scores MP2, makes them harder to slide over each other, scores MP1, so 2 marks. Okay, student 3. Now, one of the things I stress whenever I'm doing presentations such as this, I'm mentioning how the examiners go about marking and the instructions that they are given by the senior examining team, the chief examiner and the principal examiners. The instruction is very simple. Always look for opportunities to award marks wherever you can. Now, that first sentence is in fact a do not award, because do not award copper is smaller than silver. The size of copper is different than silver. That shouldn't be awarded. But look at the second sentence. So the copper iron atoms stay between the layers. Now, it's pretty obvious that they're talking about copper iron stroke atoms there. So we can backtrack to the first sentence and award that mark because of what they've written in the second sentence. Can you see how we're looking to be positive in our marking? Okay, so that can be given as an MP2. The reference to the copper iron makes it clear enough that the candidate is writing about metallic particles and not just lumps of two metals. So we can award MP2. Now, when we move down, further down, we've got to avoid the layers from sliding over one another. Now, to avoid, to me, effectively means that they're stopping the layers. And if you look in the additional guidance, it says, do not award the layers cannot slide over one another. In my mind, avoiding the layers from sliding over one another is equivalent to they cannot slide over one another. You're stopping them from sliding. And that's not true because they can slide over one another. So I, as an examiner, am not prepared to give MP1. Okay? So to avoid the layers from sliding in each other is equivalent to do not award. Cannot slide over one another. So I'm not giving MP1. So I'm only awarding 1 mark there. Some other examiners may think that that's being harsh and would be happy to give 2 marks there. But I'm telling you what I would do in that situation. Okay, there's student 4. Well, I'll give you my interpretation of this particular answer. Different types of atoms present in the structure could mean metallic and non-metallic isotopes, etc. So I wouldn't award MP2. Okay, because it's too vague. The statement different types of atoms is too vague. So the layers cannot slide, pass over each other is a do not award. So they can't have MP1. So no marks. Okay, no marks for that answer is my solution. Okay, AO2 in exams. Here are some things for you to think about when you go away from this presentation. Okay. Is it better to present facts or principles when you're teaching students to answer AO2 questions? Well, AO2 is all about applying facts and knowledge and understanding. So obviously teaching principles is significantly more important. What about when you come to question them, either verbally or in writing? Is it better to ask closed or open questions, and why? Closed questions are where a single answer is required. An open question is where there may be the possibility of more than one answer, or they have to think through a series of logical steps to arrive at an answer. So let me give you an example. What is the name of the catalyst in the Haber process? Answer: iron. Does that help them answer an AO2 question? No, because it's an AO1 question. It's a straightforward recall. However, asking the question, how does a heterogeneous solid catalyst work in a gas phase reaction, is an AO2 question, because they should have studied how the iron catalyst works in the Haber process, so they can apply their knowledge from that to then start answering the question. The gaseous molecules absorb onto the solid, where their bonds are weakened, lowering the activation energy, allowing the molecules to react to form the product molecules, which then desorb. So it's an AO2 question. That is an open question. So think about the type of questions that you ask during the course of your teaching, or indeed in your worksheets that you hand out to them, or in the homeworks that you give them, and say to yourself, are you actually preparing them suitably for answering AO2 questions? The next, is it better to set formative or summative assessments? Summative assessments are where you put them in rank order, and all you want to find out is, for your own benefit, is who is the best candidate on that particular topic test and who's the worst. And you don't feed anything back to them at all. Formative assessment is where you are giving them some form of assessment, which could be verbal, or it could be written in the form of just simple questions on a worksheet, or it could be a formal test, or it could be a formal exam, but you're giving them then feedback on that and letting them know individually what they did well and what they did not so well, and how they could improve on what they did not so well, and hopefully do better the next time they answer questions on that particular topic. So it's pretty obviously that formative assessments are far better in this respect. So try to think about how you could create formative assessments rather than summative assessments. What else could you do to prepare your students to answer AO2 questions? Well, again, that's something for you to go away and think about. But one of the things I would suggest is that you use Exam Wizard, which is one of the support materials that's available to you on the Pearson website, from Pearson's. You simply type in Pearson Exam Wizard. I'll talk about Exam Wizard, I think, a little bit later. You can actually, all the past paper questions are on there, and you can actually select on AO2 questions. And so you could select out AO2 questions and create a test on a particular topic with AO2 questions only, and give them. So the more practice you give them in answering AO2 questions, then obviously the better they're going to become. Question styles. This is something else for you to think about as you go away from this section. Think about one of the topics you teach that often has AO2 questions in exams. If you look at some past papers, you'll very quickly identify some topics where AO2 questions are regularly asked. Things like rates of reactions, things like equilibrium, energetics, entropy. AO2 questions are asked regularly in those topics. What sorts of questions do you ask in class when teaching this topic? When I was going yesterday through planning, one of the things perhaps I did miss out is you might like to put, particularly if you're not as experienced teacher as some of the other teachers within your school, i.e. you've only been teaching 1 or 2 years, then you might start wanting to put the questions that you're going to ask into your lesson plan. By the time I came to the end of my teaching career, after I'd been teaching 30 years, I knew what questions I was going to ask in every single lesson I taught. So I didn't need to write them into a lesson plan. I just simply went in and asked the questions because I'd been teaching the topic probably about 20, 30 or more times. And it becomes second nature. When you first start your teaching, of course, you don't have that bank of questions contained within your head, and it's a good idea to have them written down. But make sure that you do ask questions that are going to prepare them for AO2, that test their open. In other words, ask open questions, okay? Again, homework. Why do you set homework? Well, when I first started teaching in 1973, the reason I set homework was because I was told I had to. I didn't give much thought to what homework I set. I just found some homework from somewhere, gave it to them, took it in, marked it, gave them back again. Never gave them any feedback on it apart from the mark. And I suddenly look back over those years and think, was I doing the best job I possibly could for those students? And the answer was no. They still got very good exam results because they were very clever, despite my not so good teaching. And of course, as I became more and more experienced, I suddenly, and talked to my colleagues, I gained experience, I gained knowledge, and then I started realizing, well, hang on a moment, my homework should be more constructive and more useful than just the fact that I have to set homework, so here's a few questions for you to do. So I then started thinking about the sort of questions or problems that I actually set, and making sure I started asking my questions, what do I expect my students to gain from the questions I set? Am I actually giving them questions that's supporting and enhancing what they've done during the lessons? And now, of course, now I know assessment objectives. Will what they gain help them to answer the type of questions that are AO2 questions? In my day, we didn't have assessment objectives. So it was questions where obviously I knew they had to apply their knowledge and understanding. So I started making sure that my homework really targeted those areas where necessary. Okay. Right, so let's move on to AO3 now, and I've got the same sort of exercise for you. First of all, what is AO3? Well, it's assessing practical skills. It's gained by the students when they undertake their practical work. And this will be assessed on units 3 and 6, of course. The questions may require recall of practical techniques. There are a number, 16 core practicals, 8 at AS and 8 at A2. And the practical techniques contained with any one of those 16 practicals can be asked on any 8 of them in AS and on the 8 of them in A2. So that's 8 in Unit 3 and 8 in Unit 6. Recall of those practical techniques can be asked for. So the students need to know the procedures of those core practicals off by heart. And they need to understand why those procedures are carried out. But of course, they could be asked on the application of those procedures and techniques and the understanding to very new situations, experiments that they haven't met before in the past. They may also involve the use of experimental data and the evaluation of experimental methods or results. There's an example of a practical technique. Describe how the students should use the apparatus shown to determine the melting point range of their sample of their crystallized methyl through nitrobenzene. Okay, so the recall of a practical technique. There's an example of analysis of results. They're given the test, they're given the observation, they've got to draw an inference about 2 possible cations that could be present in A and the anion in A, okay, and then 2 gases involved in A, brown gas and gas D, identifying which relay to glow and splint, identify gases C and D by showing the naming formulae. So identifying, so analysis of results. There's another analysis of results. Don't bother reading through the whole question. Just look at the information down at the bottom. Part 1 is complete the table by estimating the volume of sodium thiosulfate that would be required in the titration at 0. plot a graph, calculate the gradient, and then part C, assume that the volume of sodium thiosulfate required is proportional to the amount of iodine in the reaction mixture, deduce the order of reaction with respect to iodine, justify your answer. So analysing results from the experiment. Okay, typical AO3 question. That one would have cropped up in Unit 6. Okay, there's an evaluation method one. Okay, the student description step A omitted important details, state how the method for step A could be changed and justify your answer. So in other words, looking at the particular method that has been given and then evaluating whether what's good and what's not so good about it and answering the questions on it. Describe what the student should do after step A before carrying out step B and justify your answer. Give a reason why step D would not work and describe how the student should dry the crystals. Okay, we're not looking here to answer these questions. I'm just giving you an idea of the types of questions that could crop up with evaluation. Okay, here's the examiner's report on this. And the reason I'm sharing the examiner's report with you, and I would encourage you to read the examiner's reports alongside the past papers and the mark schemes, because you'll learn a lot of information about what students do well and do not so well, and that could influence the way you go about teaching a particular topic. And the reason I'm sharing the evaluation one with you is because this is an area where students do less well than other areas in answering examination questions. Many candidates had a good knowledge of recrystallization and have obviously carried this out as they knew the reason for the errors in the description student one. Others would benefit from more experience with this practical technique. Many candidates knew the minimum amount of methanol should be used, but not all of them knew that this was to make a saturated solution. Okay, so we're back down to the fact that a number of students have memorized how to carry out recrystallization, but a number don't know why it's done in that particular way, what the reason is for doing it. Start asking them at which stage in the recrystallization are the soluble impurities removed and when are the insoluble impurities removed, and that's when candidates start showing that they have no understanding of why the recrystallization is carried out in the way in which it is carried out. Okay, the use of hot filtration to remove the insoluble impurities was known by many candidates. Okay, the method described by the students to dry the crystals seen frequently by candidates when describing recrystallization. Okay, it's interesting to see that some candidates understood why this would not work. Okay, right, use of data. Here they are given redox potentials, and they're asked to use those redox potentials to calculate E0 cells or to explain why a reaction cannot be prepared under acidic conditions, and then to explain in terms of standard electric potentials why manganate 7 ions can be prepared in concentrated alkaline solution. Okay, and you'll notice that they are asked to calculate E0 cell, even though this is not mentioned in the specification. The specification simply says to use standard electrode potentials to calculate feasibility chemical reactions. It doesn't specifically mention E0 cells, but when you look at past papers, you'll see E0 cells have been asked for, and therefore you need to teach them how to use E0 cells, even though, of course, it's based on rather spurious science, as I've mentioned in book 2. Okay, I've given an alternative method for using electrode potentials, which is very quick. And even though students are asked to calculate E0 cell, they can still use the method I've given in the book to check that they've calculated E0 cell correctly and come up with the correct answer. Okay, so have a look at that section in the book. Okay, and see how that can be used to quickly show whether or not their calculation of E0 cell has in fact been correct and given the correct answer. Okay, I haven't got time to go into detail. I'll just direct you to student book 2 if you happen to have a copy of it. Okay, but there's an example of use of data. Okay, and the examiner's reports was interesting here. The majority of candidates could select the correct 2-half equations needed to calculate the E0 cell value and realise that the reaction does not occur because it's negative. Those candidates who calculated a positive value should have checked their working, as they were told that the reaction actually doesn't take place. So they should have come up with a negative value. It's amazing how many students get that answer with positive value and then think, hang on a moment, it should be negative, so I must have made a mistake. So they don't then go back and check their calculation. And I've never understood why they don't do that. But there you go. There were some very good explanations about the use of concentrated alkali. However, many candidates wrote vague answers and did not make it clear which of the three half equations they were writing about, so not being precise in their answers. Some candidates showed the working for E0 cell to be negative for the formation of manganese 7 ions under standard alkaline conditions, but they then wrote a positive sign so the reaction could be feasible, so they doctored their results, which is rather silly. So obviously they can't be given credit. Okay, some terminology. These are a few terminologies that you're likely to come across in AO3. Anomaly, accuracy, precision, validity, reliability, uncertainty, and error. Okay. All of these are dealt with in a document in teaching and learning materials on the edXL website dealing with practical work. Okay, so you can download that particular document and read it, and it will talk about all these. A couple I just want to mention is accuracy versus precision are often misunderstood. An accurate measurement is one which is close to the true or accepted value, whereas if repeated measurements give the same result each time, the measurements are said to be precise. So precise measurements are those when repeated are very similar to one another. So there's a difference between accuracy and precision, okay? There's also, of course, different degrees of precision, because you can have precision of apparatus as well, as opposed to precision of measurements. So let me give you an example. An ordinary mercury thermometer that runs from 0 to 110 degrees C is likely to only have intervals of 1 degree C. But a digital thermometer is likely to be more precise because it's likely to give a measurement to the nearest 0.1 degrees C. So that is precision of apparatus as opposed to precision of measurements. A balance that is a 2 decimal place balance is less precise than a balance that measures to 3 decimal places. Okay. And the other one that often misunderstood is error and uncertainty. Error is the difference between the measured value and the true or accepted value of the thing being measured, where uncertainty is a quantification about the doubt of the measured result. So, for example, a 50 cubic centimetre grade B burette has an uncertainty of 0.05 for each measurement, giving you the total overall uncertainty of 0.10, because you take 2 measurements using a burette, okay? And if you look at the teacher practical guide, you get a lot more information on this. That's the guide that I needed to mention to you that's in teaching and learning materials on the website in international GCSE level. So go to teaching and learning materials, you'll find the teacher practical guide. Okay, so here we go. Let's have a look at a little bit more marking for you, and we may have to go through these a little bit more quickly than we did the others. There's an experiment, and the question is, give a reason why the polystyrene cup in step 1 was placed in the beaker. Don't bother reading all the information, because all we're interested in is why is the polystyrene cup in a beaker? And of course, it's to stop it falling over. Accept descriptions of falling over, allowed to stabilize the polystyrene cup, allowed to prevent spillages, ignore references to heat loss. Okay, the beaker doesn't increase the thermal transfer of thermal energy, doesn't decrease the transfer of thermal energy from the solution. So ignore references to heat loss. Okay, so there's the first one. We're looking to prevent the polystyrene cup falling over, or description of it. Okay, student 1. And you can see we have got to prevent spilling or loss of liquid. So that scores 1 mark. To support, yeah, I think we can assume that they mean to support the polystyrene beaker. References to insulation, i.e. heat loss, are ignored. So that scores 1 mark. To prevent heat losses is ignored. To insulate better is ignored. So no marks. To provide stability, you can see in additional guidance, it says allowed to stabilize the polystyrene beaker, scores 1 mark. Okay? So 1, 1, 0, 1. Hope you're all happy with those. Okay, there's nothing in the chat box, so I'm assuming that you're all happy. Okay, the next one. Okay. State the purpose of measuring the temperature every 30 seconds for 2.5 minutes in step 2. And that is to determine a consistent or steady or constant temperature before adding the sodium hydroxide. Now, before adding the sodium hydroxide is in brackets, so obviously we don't need to see that in the answer. It's we would like to see it, but it's not essential. Allow, determine a mean initial temperature. Allow reference to achieve room temperature. Ignore just to have a more accurate temperature. Do not award references to temperature cooling, since this implies the effect after the reaction. Ignore means just ignore, don't penalize. Do not award means penalize if you see it. So that could negate the mark. Okay, so there are your marks. There's student 1. It's done to obtain a more accurate temperature is an ignore. By taking the mean of all of these temperatures in the 2.5 minutes is an allow. So 1 mark. Measure the temperature before the reaction starts is not acceptable within the mark scheme. So 0. To get reliable readings is not in the mark scheme. 0 marks. To ensure that the temperature H2SO4 stays constant, and there's a little error, yeah, scores 1 mark. Yeah, to determine a constant temperature. Okay, again, you might like to use these with your students and get them to do some marking. Right, there's the next one. Explain why the temperature was not measured at 3 minutes. Now, this, of course, is where you've added your sulfuric acid, added your, which one way around it? It's adding sodium hydroxide. Right, an explanation that makes reference to the following points. The temperature will be changing because it takes time to add the 50 cubic centimeters of sodium hydroxide. And then there's a whole load of allows on the right-hand side. Okay, let's not read through all of those at the moment. Let's go straight into the marking, and we can deal with any allows as we come across them. There's the first one. You're looking for temperature is changing, or temperature not uniform, temperature still rising. And then you're looking for it takes time to add the 50 cubic centimeters of sodium hydroxide, or just simply allow that's when the sodium hydroxide was added, or because you cannot add the alkali and measure the temperature at the same time. Okay. And what have we got here? We've got temperature recorded will be inconsistent throughout the polystyrene cup. So that scores the first marking point. The temperature will be changing. So that candidate can have 1 mark. There's nothing about adding sodium hydroxide there. So can't have the second mark. Marking point, let's have a look at student 2. After 3 minutes, the temperature is rising gently. It says in additional guidance, allowed temperature still rising. So that scores MP1. And it takes time temperature for the reaction to be fixed. There's no mention of the sodium hydroxide being added. So they can't have MP2. So only 1 mark. Student 3. It will take time for the reaction to take place. And then ignore. In fact, they've got nothing written down about temperature changing. It takes time for sodium hydroxide to be added. But if you look in the additional guidance at the very last statement down there, if no other mark awarded, allow 1 for the thermometer was used for stirring, the mixture was being stirred. And there is a reference to that in their answer. So allow 1 mark for that reference to the acid was not stirred, okay? So they can have 1 mark. Right, student 4. I think the only mark there is for the temperature is increasing, MP1. No evidence for MP2, no reference to the sodium hydroxide at all, so just 1 mark. Okay, I hope you're all happy with those. I'll just have a look, see if there's anything in the chat. No, so I'm assuming that you are happy. Okay, so let's talk a little bit about doing practical work and give you some suggestions. Now, this is, of course, not Pearson's dictation to you. This is just simply some ideas coming from me. But I must mention, of course, that the specification contains a number of practical activities that form part of the subject content. Exam questions expect students to be familiar with the methods of these practicals. These are the core practicals that are listed in the specification, 8 and AS and 8 and A2. Questions also expect students to apply their knowledge of practical methodology to unfamiliar scenarios. And that's something that the students need to be aware about, that they're not going to be set questions just on the core practicals. It's not going to happen. So they better get used to it. So doing practical work. Why should students do practical work? Well, I'll share my ideas with you. One, of course, is that they need to do it in order to put themselves into a situation of being able to develop the necessary knowledge, understanding, and skills to answer the questions in Unit 3 and Unit 6. But just as importantly, as far as I'm concerned, is that practical work and theory work should go hand in hand to supplement one another. The practical work should help with the understanding of the theory, and the theory should also help with the understanding of the practical. They go hand in hand. And I'm a very, very firm believer that the two should be taught together, and making sure that you do the practical work at the same time you're doing the relevant theory. Okay, question. For right answer without working, any calculation award 3 out of 4. If the working is not required by paper setter, the rules that Ofqual set and should be abided by is a correct answer to a calculation with no working should score full marks. Okay, that's the rule that should be applied. That's all I can say. Correct answer with full marks in the calculation should get, correct answer should get full marks, okay? So if the calculation is worth 4 marks and they give a correct answer with no working, they should get 4 marks. Those are the rules laid down by Ofqual, which is the government-appointed body that oversees all the awarding organisations in the UK. And Pearson and Excel have decided to follow Ofqual regulations for their international exams to make sure that the grades awarded are compatible exams, and that applies to both GCSE and A-level. Okay, right, following on, are students getting the knowledge or skills from the practical activities you give them? Well, yes, if you're giving them the core practicals, have a look at other practicals that you actually give them, and they're probably only worthwhile giving them those practicals and getting them to do those if they're supplementing the knowledge and skills of practical work. associated with what they're likely to be asked about in the exams. They are the most appropriate extra practicals to give them. And I'm a firm believer in getting them to do as much practical work as you can possibly give them and get them to do in the time frame available to you. So extending beyond the 16 core practicals is a good practice. Okay. When do you do practical activities? Before or after the teaching the theory of a topic? Okay. And I think there are some good reasons why sometimes it's worthwhile doing a practical in order to introduce a piece of theory. Okay. This was the principle behind a whole specification that London Exams developed many years ago called Nuffield chemistry. The Nuffield chemistry textbooks always tended to work from a practical to introduce the theory. And if you do happen to have access to the Nuffield textbooks, then you might get some good ideas about practicals that you could do to introduce theory. But you might be able to get some suggestions by typing in Nuffield chemistry into a search engine in your on your computer and seeing if you come up with any suggestions. But there are some good reasons sometimes, I think, for doing practical work before theory, and vice versa, of course. Okay, now I did promise that I would tell you something about the support that's available to you, and there are two types of support. There's the online support that's available, which are the teaching and learning materials available on the Pearson website. There's past papers, marked schemes and examiners reports. And obviously you will download and look at the past papers and the marked schemes, and I'm going to try and encourage you to also look at the examiners reports, okay? Can you just, while we're dealing with the support I've got, can you please tell us from where you'll get the practical videos related to A-levels? And can you please share the link with where we can get the right videos? Well, I can't share the link with you, but what I would suggest you do is that you type in Royal Society of Chemistry into your search engine and then go to the Royal Society of Chemistry website where you can sign up. I believe that overseas teachers as well as UK teachers can sign up to the teachers website, which will allow you to have access to all of their results materials free of charge. I'm not sure how many resources you can download per day. It may be limited, but they may get access to all of them. So you can actually sign up on the Royal Society of Chemistry website, and that will give you access to some of the videos. And of course, there are videos. They've put some of their videos also on YouTube. And there are a number of occasions in which I've used them. I think I mentioned yesterday that I covered for a colleague of mine in Cyprus recently. I live in the UK and I went out to Cyprus to help her out. The website, Royal Society of Chemistry website, the Royal Society of Chemistry. Okay, that's the website. But you need to sign up to teachers. If you go into the Royal Society of Chemistry website and click on education website, then you will be taken to an area where you can sign up as a teacher. Okay, the Royal Society of Chemistry. That's it. Yes, you got it. The Royal Society of Chemistry. Okay, I did some teaching for a colleague who was taking maternity leave. And it's a private college with no laboratory facilities because she's teaching top-up work. And I wanted to teach recrystallization to them, and obviously I couldn't do the practical work, so I went to the Royal Society of Chemistry website, and being a member, I'm a fellow of the Royal Society of Chemistry, as you could see from the first slide, FRSC, and I downloaded all the videos dealing with all the various steps of the Royal Society of Chemistry, the crystallization, and was able to show them each individual step being performed, which was an alternative to them actually doing the practical themselves. They are being taught in schools as well, so they did have the opportunity to do the practical. Okay, right, so let's move on this. There are also teacher resource packs available online, okay? But there are published resources, which are the student books, which I and Jason Murgatroyd have co-authored. You'll see my name on the front cover if you've got them. And there are, of course, lab books as well, which are quite useful. Right, now let me just show you the landing page for the teaching and learning materials. What you need to do is to type into your search engine Pearson qualifications, okay? So type in Pearson qualifications and then go to international advanced levels and then click on chemistry. And that will take you to the main website. And one of the little icons on the right-hand side will be teaching and learning materials. And when you click on that, this is the landing page that you will get. And you can see on it that you've got specification and sample assessment, exam materials, which are all the past papers, mark schemes, and examiners' reports. And you've got 41 teaching and learning materials. Okay. And in those teaching and learning materials, you will find the following. Right, just as you're looking at that, I'll answer these two questions. Can you please tell the name of the book you mentioned, Nuffield, Teaching Theory from the Practical? Yes, just type in Nuffield Chemistry into your search engine and seeing what information you can get. That's the best I can do, okay? You've got to bear in mind that this Nuffield course was written back in the 1960s, 1970s. Can anyone explain if there's any uniform mark relevance to Pearson Edexcel A-level exams? Yes, Pearson A-level exams do use uniform mark schemes. Okay, they do use uniform marks so they can make sure that a mark gained in one paper is equivalent to the mark gained in another. I mean, 53 marks in one paper could be equivalent to 49 in another because the second paper could be slightly more difficult or demanding than the first paper. Uniform mark schemes make sure that 53 and 49 are equivalent marks. So we do use uniform marks. Okay, so you've got exemplar material, getting starting guide, math support, teacher practical guide, transition guide, past training guide. I mentioned all of those yesterday, so I'm not going to go into great detail about those again, okay? But they are all there. So I'd advise you to try and look at as many of those as you possibly can. There's something else come up to the chat. Can you please explain, because yesterday I couldn't hear the initially, to 40% of AS and 20% AL when you were explaining the examination different units? Yes, that's because the marks obtained in AS count towards half of the international A level. Okay, so if you get, let me give you an example, if you get 300 uniform marks in your AS exams, then that will count as 50% of the overall marks in IAL because there were 60 uniform marks in IAL. Okay, so it just counts half. AS counts half of the AL. That's why it counts 20%. Okay, I'm not sure I can explain that any better. Okay, past papers and mark schemes. Okay, as I said, they're also available on the Pearson website. Make sure you make good use of them. They're listed under the exam materials of the Teaching and Learning website, which is there, which I just pointed out. Okay, now the published resources, of course, are the student books, which you'll see my name there on both books, and Jason Murgatroyd co-authored. I dealt with the physical chemistry and a few other aspects in the chemistry there. Jason largely dealt with the inorganic and the organic. David Scott wrote the, what are they called? I've forgotten what they're called now. The thinking bigger exercises, okay? He didn't write any of the theory. He just simply did the thinking bigger exercises, okay? The student book 1 covers the IAS content, and student book 2 covers the IAL content. Okay. Can we get the textbook on the Pearson website, or do we need to purchase it? You need to purchase it. Okay. Although you may be able to get, and I say may be able to get, inspection copies free of charge. I don't know whether you can or not. You may be able to get inspection copies free of charge. I will point out, however, that it is not a requirement of teaching the specification that you use these student books. You don't have to use them if you don't want to. You can use any student books that you like. But do bear in mind that other books may not contain all of the statements in the specification. They may not contain all the specification content. And if that's the case, you will need to supplement it with your own notes. Also, some other student books may have material in there that is not on the specification, and students may think they have to learn that as well. And so you need to point that out. But that doesn't stop you using other textbooks, okay? That's just a warning for you if you do use other student textbooks, okay? The other published resource is, of course, the lab book. And I mentioned the lab book yesterday, and I mention it again because it contains instructions for each core practical, together with some questions to ask. The students can enter their results and observations directly into the book. So they've got all their practicals together in one book, rather than having them spread out throughout the whole of their notes. So that might be useful for some students in their organisation. My experience of teaching A-level students for over 30 years is that some students are very good in their organisation and some are absolutely appalling. So any help you can give students in their organisation is very, very worthwhile. So you may think having the lab books are very helpful for them. Unfortunately, you have to pay for them, but if you have to pay for photocopying, and you have to photocopy and print, and you have to print, download, print, and then photocopy all the instructions for the core practicals, and then hand them out to each student individually, it may work out cheaper to buy the lab books than to pay the photocopying bill to the school. If you don't have to pay for photocopying, well, you're okay, you're in luck, aren't you? So you don't need to purchase the lab book there. But as I said, the lab book may prove cheaper than photocopying the material. But the major reason, I think, for the usefulness of the lab book is to have everything in one place. And if you do get an inspection copy of the lab book, have a look to see how useful it is. I think you'll find it's a lot more useful than just having everything in one place. There's a lot of information in there that's well worthwhile having at your fingertips. Now, the last thing that's useful for you is the subject advisor. So if you've got any real questions you want to ask that have not been answered today and crop up in the future with regard to this qualification, anything at all to deal with the exam papers, the marking of the exam papers, not understanding why a particular answer is included, or why an answer is included when you wouldn't have thought that was worthwhile, send it to teachingscience@pearson.com, and Tim or one of his colleagues will pick it up and will try to get back to you with an answer as soon as they possibly can. Right, whilst you're just looking at that, I'll look at the 2 questions. The hard copy textbook, very difficult to get in Nigeria. Any help? I'm afraid not. Sorry, I wish I did have some suggestions. Okay. I don't know. I don't know Africa very well. I would suggest that the best thing you could possibly do would be to contact your subject coordinator out there, the area manager for Pearson EdXL. And I'm just trying to think who it is in Nigeria. I can't remember the name for Africa. I know Christine Evans deals with it overall, but there is a Pearson representative out there who's called the Pearson manager, and your subject officer should have the name of that person. And if you contact, and I think it's a him, but please don't hold me to that, it could be a lady. If you contact that person, then they might be able to help you there. Okay, sorry, I can't be of any help. So do try to get your contact your Pearson representative out there. There definitely is one in Africa. I know that for certain because I'm sure I'm linked with the person on LinkedIn. I'm absolutely sure I am. So that might help. Okay, so there's your subject advisor. Okay, so the next thing is any more questions? We've got a couple of minutes before I have to end the slideshow. So if there's any more questions, then please put them into chat. If not, then obviously we will end the slideshow and I will wish you a good rest of the day. Right, there's something cropped up. Oh, just says simply thank you. You're more than welcome. It's been my pleasure. Okay. Nice to receive the thanks, but it is my pleasure.